So I'm Anders. I'm one of the students who worked under Evo this summer. And so today I'm going to talk about how you can use the Popper CLI tool to make computational science projects more reproducible. So there's been this issue recently in computational science where it's just difficult to replicate results. And one of the reasons for this is that research in these fields increasingly is using complex software, and like statistics and machine learning tools. And that software might have a lot of dependencies, say like compiled code, maybe for a specific CPU that then has bindings and some interpreted language. And all of that introduces just a mess of dependencies that and that might introduce incompatibilities if you try to run the code yourself, and then you just won't be able to run it. Then a second reason for this is that, and that's kind of more specific to computational fields, such as like bioinformatics, which I picture here, you often have really complicated data processing pipelines with many interdependent steps from the raw data to the final result. And so, if I don't document these steps properly, well, you'll have a hard time replicating a workflow. You kind of have to guess in what order do you do what if I don't explicitly do that, and that's less than ideal from a reproducibility standpoint. Okay, so one way of addressing that is using Popper. So Popper is a workflow execution engine, which means I define some sort of step I want to execute in a file, and then it'll run it in a container, and that kind of addresses both of these issues. First of all, a container approach just kind of smoothes over all the problems that you have from different software environments. And then secondly, specifying a workflow explicitly avoids all the problems from data pipeline complexity, because it's just all there explicitly documented. However, it's not quite a perfect solution because it requires the user to know how to use all these DevOps tools. And a lot of people in computational fields would benefit from this approach that would, help them make their work more reproducible, but don't have prior experience with these tools, especially Docker. And so my goal this summer was to create a collection of tools and tutorials that help smooth out this learning curve and get people up and running with the Popper approach. So a first aspect with this was writing tutorials for developing Popper workflows, and which were oriented to Python and R users. And it goes over the main things you'd want to do using a Popper in a computational setting. So executing a computational notebook, best practices for managing these software dependencies, and best practices for structuring your project in a sensible way, such that other people could pick it up and use it immediately and understand immediately what's going on. A second aspect of that was making it really easy for people to get started with using that approach from the beginning of their project. So I made templates that kind of bootstrap Popper workflows for Python or R projects using Cookie Cutter, which is a command line utility that generates project structures from some sort of definition. And this also included making specific Docker images that are specially configured to work nicely with the Popper engines. And then the last aspect of that was writing some examples that show end-to-end machine learning project in Popper, because there are already quite a few examples in other fields using Popper, in particular systems analysis, but there wasn't really a high-quality example available yet for machine learning or statistics or similar fields. And this just kind of goes over all the different things you typically do in such a project and shows best practices for doing so. So one of the most complicated and time-consuming things this summer was actually modifying Popper to get it to work in the way I needed. Because there's this idea that you want to minimize the distance between development and production, where production is, in this setting, releasing your code to the public so that people could take it and replicate it. And so you want users to develop in Popper from the beginning. But computational users will typically want to use some sort of computational notebook like Jupyter or RStudio, and Popper did not support that at the beginning. And so there is a lot of work before doing anything else and adding these features. Okay, thank you. And I encourage you to check out the project on GitHub, and all the work I did is available on our repositories and under our documentation. And thanks to Ivo for his mentorship this summer.